My name is Shane Healy, and I'm here to talk to you about buoyancy with my roommate Emmett.
Hi.
And some Tupperware, some bumblebee tuna, and a fish tank. So Emmett, what do you know about density?
Not much, Shane, but I'm ready to learn.
So density basically is the amount of mass in an object divided by the amount of volume it takes up. Do you think this can of bumblebee tuna will sink or float in the water?
I'm not sure.
Looks like it sinks. It's because it's more dense than the water.
I see.
So, based on that, do you think this is more or less dense than the water?
Less.
So is it going to sink or float?
Sink.
It's probably going to float.
Okay.
And it does. Newton talks about how equal and opposite forces acting on each other. So right now the force of buoyancy must be equal to the force of gravity in order for the Tupperware to stay in the same spot.
Gee, Shane, this one's pretty light. Looks like it's 41 grams. This seems to be significantly heavier. It weighs in at a whopping 175 grams.
Tuna here is 500 centimeters cubed, and the Tupperware is 740 centimeters cubed. Makes the density of tuna equal to 0.73 grams per centimeter cubed, and the density of the Tupperware to only 0.05 grams per centimeter cubed. Let's find out what the density of water is by weighing that also.
Don't mind if I do.
It looks like it comes in at 130 grams in the same amount of volume as the tuna fish, which was 500 centimeters cubed. So, by taking the same amount of weight and creating more volume, we are decreasing the density of the tuna fish. Now let's put this in the water and see what happens.
Shane, it appears to have sunken, but only slightly.
Yes, only a small portion of the Tupperware is underneath the water.
Why is it that only part of the container sinks below the water?
The force of buoyancy has to be equal to the weight of gravity on this object. And we can figure that out using Archimedes' principle, which says that the weight of displaced fluid must equal the weight of the object. So that weight of water should equal the weight of the Tupperware and the tuna fish. So here we have the weight of the Tupperware and the tuna fish coming in at...
Looks like it's 216 grams.
If we can measure the weight of water, if you could fill that up about a third of the way.
Certainly.
Right about there. How do we do?
Looks like it's 210 grams.
So, in conclusion, Archimedes' principle was almost dead accurate. Just based on estimating the amount of water that we displaced, it equals the weight of the tuna fish and the Tupperware.
Not bad.